Welcome and good day everyone. So today we go to chapter 5.5, which is mutual inductance. First you have to define what is mutual inductance, and second you have to use mutual inductance, which equals to M is equal to mu naught N1 and 2A over L between two coaxial solenoids. Okay, so we go to definition of mutual inductance. M. Okay, so before we go further, kita tengok dulu what is meaning by mutual induction. Kita ada dua, mutual inductance M and mutual induction. Mutual induction is usually a process of induce MF in a circuit by changing current in another nearby circuit. Alright, so kalau kita perasan kat sini, we just connect the first coil through the power supply or through the battery. Okay, battery. And then kat sini untuk coil ni akan ada change in current. Okay, akan ada change in current. So bila ada change in current, mestilah ada change in magnetic flux. Okay, because flux equal to directly proportional to current. Okay, so the change in current in coil number 1, okay, will experience to coil number 2. So coil 2 will experience EMF induced due to change of current in coil 1. So then galvanometer pun akan deflect. Okay, so the increasing of current in loop number 1 will produce the change in magnetic flux. This changes is experienced by coil 2. Okay, will experience by coil 2 that place nearby. Okay, we increase or decrease the current, so meaning they are changing in a current, so then they will also changing in magnetic flux, so akan dirasai oleh coil number 2. And then according to Faraday's law, the loop 2 will experience an induced MF. So that's why kita boleh bagi tahu EMF induced in coil number 2 is directly proportional to the rate change of current in coil number 1. Okay, EMF induced in coil 2 due to the rate change of current in coil number 1. Okay, the production of the induced current in this loop that caused by the change in current in the neighboring loop. Inilah yang dinamakan sebagai mutual inductance. We go to 5.5, which is mutual inductance. Okay, so first you have to know what is defined by mutual inductance, which is M. So before we go further, kita tengok dulu what is mutual induction. Mutual induction actually is a process of producing and induced MF in one coil due to the change of current in the another coil. So maksudnya itu directly proportional to the rate change of current in coil number 1. Ingat itu. Okay, itu change of current coil number 1. Kalau E1 directly proportional to the rate change of current in coil number 2. Kalau 1 coil number 2. Okay, the current I1 flows in coil 1 produced by the battery in the external circuit. The current I1 produces magnetic field lines inside it, and these lines also pass through coil number 2. Alright, so current 1 changes with time. The magnetic flux through coil 1 and 2 change with time simultaneously. Okay, kat sini lah. Yang kat sini saja kita connectkan pada bateri, tapi akan dirasai juga pada coil number 2, di mana coil number 2 dia punya galvanometer will show deflection, meaning there are current in coil number 2 due to the changes of current in coil number 1. Okay, kita tengok pula what is mutual induction. Inductance M is the ratio of the induced MF in a coil due to the rate change of current in another coil. Okay, so kita kat sini the EMF induced in coil number 2 is directly proportional to the rate change of current in coil number 1. So we have E2 is equal to negative M di over dt. Okay. Vice versa, we have E1 equal to negative M di2 over dt. Okay, where M12 sama juga dengan M21 is equal to M. Okay, so we do the differentiation. Okay, so differentiate lah kat sini. So kita tahu sebelum ni kita belajar EMF induced is directly proportional to the rate change of magnetic flux. So flux tu EMF tu flux tu sama juga dengan itu equal to M2 flux 2 over dt. Okay. Tapi untuk kita punya mutual inductance, EMF induced is directly proportional to the rate change of current in coil number 1. So E2 equal to M di1 over dt. So kita samakan dua ni. Okay, dengan ni. So kita akan dapat apa? Kita akan dapat M2 flux 2 over dt equal to Mi1 over dt. So to have M, we have M2 flux 2 over I1. Alright, so kita state yang ni. Kita state yang di sini. Okay, di mana M2 flux 2 over I1 is the magnetic flux linkage through coil 2, and then N1 plus 1 over I2 magnetic flux linkage through coil number 1. Inductance for two coaxial coils. Okay, coaxial coils macam ni lah. Kita consider a long solenoid with length L, okay, and cross sectional area A, closely wound with N1 and N2. Okay, so the current for N1 and N2 is same. Okay, we also have one current. When current I1 flows in the primary N1, it will produce B1. So B1 we already know that mu naught N1 I1 over L. Okay, so sebenarnya kita belajar dah. B equal to mu naught N I over L. Ni untuk solenoid. Okay, mu naught N1 I1 over L. L is the length of the solenoid. And then we know what the magnetic flux. Flux equal to BA. So kita dapatkan flux sama dengan BA, B1A. So flux 1 equal to B is mu naught N1 I1 over L darab dengan A. So we got this one. Alright, so if there are no magnetic flux linkage, so flux 1 equal to flux 2. So then if the current I1 changes, the EMF induced in the secondary solenoid, therefore the mutual inductance occur and given by, so M equal to N2 flux 2 over I1 sama juga dengan N1 flux 1 over I2. So kat sini kita ada M equal to N2 over I1, okay, flux 2 sama dengan flux 1 equal to mu naught N1 I1 A over L. Okay, so masukkan ni mu naught N1 I1 A over L. So that's why lah kita akan dapat kat sini. So kita dapat M equal to mu naught 2A over L, because I1, okay, kita potong kat sini. I1 dengan 1 ni current same, so kita potong kat situ. Okay, alright, go to the exercise. For linear outcome 5.5b, you have to use mutual inductance M equal to mu naught N1 N2 A over L between two coaxial coil solenoid or two coaxial coils. Alright, so for example number 11, a current of 3 ampere, okay, flows in a coil C and produce a magnetic flux of 0.75 Weber. When coil D is moved nearer to coil C coaxially, a flux of 0.25 Weber will be produced in coil D. If coil C has 1000 turns and coil D has 5000 turns. Calculate the self-inductance of coil C and the energy stored in C before D is moved nearer to it. Okay, so first we have to take out all the information given. So we have current, okay, current C 3 ampere, IC 0, magnetic flux, okay, magnetic flux 0.75 Weber. Okay, so when a coil is moved nearer to coil C, a flux, okay, flux D 0.25 Weber. If the coil C and C 1000 turns and D is 5000 turns, calculate the self-inductance. Okay, so L coil equal to N coil plus coil over I coil. Okay, so kita ingat balik, L sama dengan apa? L sama dengan flux over I, kan flux sama dengan Li, so kita dapatlah L sama dengan flux over L. So jangan lupa letakkan N for the number of turns for L coil, and coil is 1000, flux coil 0.75, I coil 3. So L coil will be 250 Henry. Okay, calculate the mutual inductance of the coils. Okay, so nak dapatkan mutual inductance of the coil, so kita tahu M sama dengan N D flux D over ID, and D is 500, flux D 0.25, ID is also 3, because the two coils, the current flow in 3, the current of 3 ampere flow in coil C, okay, tapi dia lilit yang sama, so kita akan ada D pun 3 amperes. Okay, so we have 417 Henry for mutual inductance of the coils. If the current in C decreases uniformly from 3 to 0, so I initial is 3 ampere, I final is 0 ampere, T equal to 0.25. Second, calculate the induced EMF in coil D. So EMF D equal to negative M di C over dt. Okay, because ingat, the EMF induced in coil number 2 is because the change of current in coil number 1. Okay, ingat, yang tu, yang ni 1. So this one is D, this one is C. So ED equal to negative M is 417, I final 0, 3, 0.25. So AD equal to 5004 volts. Okay, for number 12, two coils X and Y are magnetically coupled. The EMF induced in coil Y 2.5 volt when the current flowing through X changes at rate 5 ampere per second. So dIx over dt equal to 5 ampere per second. Determine the mutual inductance of the coil. Okay, so Ey equal to negative d Ix over dt. So don't forget to put the M here. Put the M because it is the mutual inductance. So Ey equal to M kita nak cari, then dt is 5. Ey is okay 2.5. So the mutual inductance is 0.50 Henry. Okay, Henry actually. we can have a 0.50H. Okay, B, the EMF induced in coil X. Okay, EX, if there is a current flowing through Y which changes at rate, okay, so DIY over dt equal to 1.5 ampere per second. So EX equal to negative M DIY over dt. So EX equal to M is 0.50, 1.5, so EX equal to 0.75 volt. Okay, number 13. Two coils X and Y are magnetically coupled. Coil Y, okay, and Y is 50 turns. The current 2.5 flowing in coil X. IX 2.5 ampere. So that the magnetic flux pass through Y. Okay, so flux Y 35 milliweber. Determine the mutual inductance of the coil. Okay, the mutual inductance of the coil. So we have M equal to NY flux Y over IX. Okay, so M and Y we follow flux Y 35 times 10 power of negative 3, IX is 2.5. So the mutual inductance will be 0.70 Henry. Okay, B, the current of 2.5 ampere which flows through coil X changes to 4.5. Okay, so IX is 2.5 ampere. IX initial, IX final 4.5 ampere. Time dia is 2 millisecond. Estimate the average EMF induced in coil Y. EY berapa? Okay, so kita tahu Y equal to negative M DIX over dt. Okay, so EY equal to M is 0.70, X 4.5 minus 2.5 over 2 negative 3. So EY equal to 700 volt. Okay.